Hello everyone. In today's video, I will be going over the Unit 2 review for our test coming up. So first off, 1 through 10, it's a little confusing what you're supposed to do here, but this is a matching problem, and it's almost like a double matching because each graph here has two things that you're going to put with it. So there's kind of a trick to this, a shortcut if you will. For each graph, you're going to put the name of the function in one blank, and then in the other blank, you're going to put the equation. So one little shortcut you could do is match up the names and equations first. That way you already know which pairs go together. So I'm going to do that actually. So this first equation, we have that squared here. This is like x squared. For the parent graph, that's our quadratic function. So that goes with v. So a and v go together. B, this is like square root x. So that's the square root function. So that's going to go with z. This one here, c, this is the absolute value. We know by this symbol, absolute value function. So it's going to go with w. Two more. Here we have the cubed, x cubed, so that's cubic. So d is going to go with x. And then obviously these are going to go together. This is our exponential where we just have 2 to the x, for example. So e is going to go with letter y. So now, number 1, this has that disco right shape. That is a cubic function shape. So now I know I'm going to put x and d in both of these blanks. So x, it's a cubic function, and d, this is what the equation will look like. And that's all you have to do. You don't have to fill in the equation for this specific graph. You're just matching this is the name of the function, and this is what the equation in theory would look like. Of course, we could change h and k based on the graph, and then we could have a number in front as well. Number 2, this looks like the square root, except it's upside down. Square root is normally like this. So this is the square root function. Z and B. Number 3, a lot of you were stuck on this one. You could process of elimination your way through this problem. The only shape that this comes close to being is the cubic, which it is. So number 1 is how it's supposed to look. What happened to get to here? First, it was reflected, so the up went down, and then the down went up, so that's why it looks flipped. The other thing, it was stretched a bit. Or actually, this looks like a compression. I'm not sure because I can't see the values very well, but something was definitely changed about the a, which is why it looks wider than it's supposed to. So yes, this is still a cubic function, so I'm going to put x and d there. And there's 2 of each, so I'm done with cubic now, so I know I won't use this one again. 4, here we have that v for absolute value, except it's upside down, so this is a reflected v, but no less it is absolute value, so w and c. So w, it's absolute value function, c, this is what the equation form would look like. It's not the exact equation, but this is where we would start. Here we have that U shape, that goes for quadratic functions. So this is V and A. Reminder, we did a matching activity with these graphs early on in the unit, so if you want to pull that out just for reference to help jog your memory here, you can do that. I'm going to do this 2 more times. Not 2 more times, 4 more, 5 more times, goodness. Okay, this one. This is an exponential function. You could mistake it for a square root, but it really flattens out here on the x-axis, so this is exponential. So we're going to use letters y and e. Here we have another quadratic. It's that u, except it's upside down. So this is what a reflected u would look like. So we're going to use v and a again. And that's the only other time I'm going to write that. So we've used both quadratics. This one is the square root function. It has been, it looks like, I'm not sure what happened to it. No, I think the graph has just shrunk down so we can actually see the numbers. This is what it's supposed to look like if there's no transformations made to it. So square root, this is z and b. And I will not be using that one again. So we're done with square roots. Here's our other exponential, and they even give us the equation in the graph, so this one's pretty easy. Y and E. And here is the typical V shape for the absolute value function. So W and C here. Again, you will use each pairing twice. All right, that's the first 10. Number 11. Given the following transformations, write the equation of the function with the following transformations from the parent function f of x equals x squared. Shift of 4 units to the right and 2 units down, a reflection over the x-axis, and a vertical compression of 1/2. And then the general form is f of x equals a times x minus h squared plus k. That's a lot of information we're throwing at you. So when you do problems like this, please take your time, slow down, read them carefully. Don't fly through these. And unfortunately, this is kind of smushed together, so I don't have a lot of room here. So I am going to rewrite some of this information. 4 units right. I'm going to put a comma here. I know it's not there, but these are 2 different transformations. 2 units down. Reflection. And I'm not going to specify x-axis. It's always x-axis in here, unless it's exponential, which we wouldn't do that to you. I'll put reflection and vertical. I'm running out of room here, so I'll just put compression. Compression of 1/2. Okay. So now let's assign letters to these so we know where they go in this function. So 4 units to the right. I'm going to summarize this information here before we do it specific to this problem. So we have several different movements here. Left or right. So that's going to look like this. That's our H. H is a left or right movement. Reminder, H is always inside with the X, and the X-axis moves left or right. So it's kind of your hint to remember which direction H goes. So if it says left or right, you're going to be putting a number in for H. Up or down, that's your K. K is on the outside. K goes up or down on the Y-axis. Now the ones that really trip people up. If you see reflection, remember reflection is where we just flip the graph over. So for instance, if we look at these absolute values, this is the normal way we should write it. This is without reflecting it. And this one is after you reflect it. Notice that the V is completely upside down. That happens when you have a negative A. If you have a negative on your A, negative in front, that's the reflection. And then lastly, if you have a stretch or compress, stretch or compression, that is A. And I want to add a little caveat here. A equals 1 unless otherwise specified. So what I mean, if you don't have a stretch or compression, then A is just 1. You don't have to write a number there. We just assume it's 1. A is never 0. So if we don't have an H or a K, I told you guys in class, then you can treat them as 0. You cannot do that with A. A is 1. If you put 0 in for A, it's going to have major consequences for the equation, whether you realize it or not. So these are kind of the directions you want to keep in mind as we're doing these problems. And actually, I think I can put this up here. Keep it in view. Oh yeah, that'll look good. Let me move this up a little bit more. Okay. So we have 4 units right, left or right, that's an H. Now 4 units right, that's a positive movement. So H equals 4. It's a positive 4 since we're moving it to the right. I'll just write it as a plus 4 to specify. 2 units down, up or down, that's K. So now down is a negative movement. So K equals negative 2. Reflection and compression of 1/2. I put these together and notice they are together here. That's because both of these affect A. So I'm going to put them together. So reflection, that means negative A, and compression of 1/2, that means A equals 1/2. So if I put them together, A equals negative 1/2. When I put all of that information together, A is by itself negative 1/2. Now I can put all this into my equation. I have f of x equals A is negative 1/2 times x. X is always going to be x. You don't ever put anything in for x. Minus, that minus is always there. H is a positive 4, so it's just minus 4 squared. And k is negative 2, minus 2. And there's my answer. Reminder, this minus is why this changes. So now when we look at this, it looks like our h is a negative 4. But remember, we always look at this and think of it as the opposite. So it actually is a positive 4 in disguise. So that's my equation. It is a little bit of work, but it's just about, can you break it down? Number 12, given the following function, f of x equals 5 times the square root of x plus 7 plus 4, state all transformations. So the parent graph, and this is where this comes in handy, is f of x equals the square root of x. No transformations. So any extra number here is a transformation. So let's see what happens with each one. 5 is in front. 5 is A. And if we have a whole number bigger than 1, that means this is a stretch. So this means stretch of 5. That's all that means. X plus 7. Remember, that means that h inside here is actually negative 7. So when we have negative 7 for h, that means left 7. Remember, you do the opposite. That looks like right 7, it's actually left 7. Plus 4. This is an up or down movement. We read it as it says. So if that says plus 4, that means it's up 4. This does not have to be written in any special way. You can write it as a bullet point list, kind of like what I did. You can write them out all as just a series. It doesn't really matter. As long as your answers are correct, that's what matters here. Next page. 13, given the following function, f of x equals x minus 2 squared plus 1. State all transformations, same thing. I have a little bit more space here. This squared here tells me this is quadratic, and the parent graph, meaning the unaltered basic graph here, is just x squared. So anything extra here means we have a transformation. So we have x minus 2. This means we interpret h as positive 2. So when I put that in there, it becomes a negative 2. H is positive 2, so that means we're going to move right 2. Remember, think of this as the opposite. It's actually a positive 2. So it's not left 2, it's right 2. Plus 1. This is the k spot. K is up or down. You read it exactly as it says, so that means up 1. And that's it. Number 14, given the graph to the far right, describe the following characteristics. Identify the vertex. The vertex is that very bottom point of the graph, or if it's flipped over itself, it's the very top point. It just depends. Here, it's this one. So our point is 2, negative 3. And we do have the equation to compare to it. Notice that looks like a negative 2 here. Remember, you change it from a negative to a positive here. And then the negative 3 doesn't change. Notice how that works here. State the domain. As we move across the graph, because domain is your x values, and you move from left to right. As I move from left to right on the x-axis, I've got arrows pointing towards negative infinity on the left and positive infinity on the right. And in between the two, I have solid points in a nice solid graph. This is negative infinity to positive infinity. Range, your y values. from bottom to top. So now we're looking at the y-axis. Now, they cut off the y-axis pretty early, but if we move down further, -4, -5, this graph stops here at -3 and then continues upward. So all of this area under here has no graph. So on the range, the graph does not start until -3. There is a solid point at -3, so we do have a bracket. I can use the Post-it note to demonstrate. We start at the bottom, work our way up. Graph doesn't start till -3. And then we follow it up, and both arrows point up towards positive infinity. So it's -3 to infinity. Make sure you're writing this in order from smaller number to larger number. Don't flip these, that would be wrong. X-intercept, where does the graph cross the x-axis? And we should have written it like this, because there could be more than one answer, and there actually is more than one answer here. X-axis is here. We have 2 points, -1 and 5. You do have to write them as actual coordinates. So this would be -1, 0, because y is 0 here, and +5, 0. That's the correct answer here. Make sure you write them as points. If you write just the numbers, that would be wrong. Y-intercept, same type of question. Where does it cross the y-axis? Looking on the y-axis, crosses at -1. Our point is 0, -1. X is 0, y is -1. Number 15, same process. Identify the vertex. This time, this is an upside down U, so it's actually the highest point up instead of the lowest one. This is 1, 4. Domain. This is moving down, but also towards the left. It's moving down and left, so it's going to eventually make its way over here. This is moving down, but also to the right. Eventually, we'll make it over here. So we got arrows pointing to -infinity and positive infinity. And then the graph in between is solid, no holes, no jumps. This is -infinity to positive infinity. Range, we start at the bottom of the y-axis, which is -infinity. Every so often I do that. -infinity. If we follow the graph upward, we run into arrows, so it's definitely heading towards -infinity, so it's going to start there. There is no question about that. And then we follow the graph upward, and we hit a point at 4 on the y-axis. And then the graph stops. There's no more graph after 4. And there's a solid point, so we'll use a bracket. And that is our range. Smallest to largest, don't flip these. X-intercept, where does it cross the x-axis? Let's take a look. X-axis is here. It crosses at -1 and 3. Again, write these as points. This is -1, 0, and 3, 0. Y-intercept, same thing. Where does it cross the y-axis? Look at the y-axis. Our point is right here. Crosses at 0, 3. That's at 3 on the y-axis. 0, 3. Must write it as a point if you want credit. Do that again. Number 16. Given the graph to the far right, describe the following characteristics. This one's different. It's already asking about an asymptote. That means this is an exponential function. This is the only function that has an asymptote. The asymptote is this dashed line here. And we're going to draw this out further so you can see what else happens. It's going to keep going to the right. This graph is going to keep moving to the right. And it's going to hover above this asymptote. It's never going to touch the asymptote, and it's never going to go underneath it. It can't. It won't allow it. So this asymptote here, it's a line, so it needs to have an equation. It is y equals 2. Remember, that's how you write the equation of a horizontal line. If you don't remember, you can easily find a YouTube video or Google equations of a horizontal line. They all look like this. y equals a number, whatever number it is going through. It hits 2 on the y-axis and has 0 slope. That's why it's such a small equation. State the domain. This arrow, while it is pointing up, it is moving slightly to the left. You can see that. So it will eventually make its way over here towards negative infinity on the x-axis. And then we can clearly see it's moving towards positive infinity over here. And then in between, we've got solid lines, solid points, nothing wrong. Negative infinity to positive infinity. State the range. Again, that's our y values. Start at the bottom of the graph. Bottom of the graph is negative infinity. Top of the graph is positive infinity. Let's see where it goes. Follow it. There's no graph down here. This graph does not start until we hit that asymptote at 2. I want to re-clarify. This graph will never actually touch the asymptote. I know it looks like it here. It will never. Trust me. It does not. So it will get as close as it can to 2 without actually touching 2. So 2 is the starting point of the graph, but 2 is not part of this graph, part of this range. I can't get 2 out of this equation. It's not possible. So I'm going to put it at 2, but parentheses. It's not included. Then I follow it upward. Got solid line here, solid graph. And I made an arrow that, yes, is moving towards the left, but for the y-axis, it is moving up. We can see that. So it is going to continue on up to infinity. X-intercept. Where does it cross the x-axis? Nowhere. We don't have any. Remember, that is an option. If the answer is none, do not write 0. Write none. Y-intercept. Where does it cross the y-axis? Here at 3, write it as a point. 0, 3. X is 0, y is 3. New type of problem, graph the following function. F of x equals x plus 3 squared minus 7. So here we don't need to pull out all of the pieces we were just looking at. We can focus on other parts of the equation. When you're doing this, you want to think about a few things. You want to think about the parent graph. Parent graph would just be the squared, so x squared, y equals x squared. The shape, that is going to be important. You have to know what this is supposed to look like, because your graph's not going to be perfect. It's going to have like 3 points, and it's going to have the shape. If you have all that graph correctly, it's going to be correct. Quadratic, x squared, has a U shape. Make sure you graph the shape correctly. Now, we need to be able to graph it. We need 3 points. In the middle here is going to be my vertex. So let's look at our equation. Our equation is f of x. I'll rewrite it over here. I'll change that to y equals x plus 3 squared minus 7. The vertex comes from the equation. Remember, you look at the number next to x, and you mentally, don't actually change this, but mentally change this to a negative 3. Because if it looks like a plus 3, x is actually a negative 3. And then our y value is just negative 7. So negative 3, negative 7. That's our vertex. Inside change, outside keep. Inside changes to negative 3, outside keep it, negative 7. So this is my first point. From here, I need 1 point to the left and 1 point to the right of negative 3 to complete my chart. If you want to graph this first, if that helps, you can do that. Negative 3, negative 7. Right there. Negative 3, 1 point to the left is going to be negative 4. And 1 point to the right is going to be negative 2. So now I need to find these y values to complete my graph. Once you have an x, if you want to find y, all you do is plug it in. So x equals negative 4. Let's find y. Plug it into the original equation. Don't change anything about the actual equation. We're not changing this to a negative 3. So we have x is negative 4 plus 3 squared minus 7. Negative 4 plus 3 is negative 1 squared minus 7. Negative 1 squared is positive 1 minus 7 is negative 6. And now I'll repeat for negative 2. Plugging in negative 2 for x, I have negative 2 plus 3 squared minus 7. Negative 2 plus 3 is a positive 1 squared minus 7. 1 squared is 1 minus 7, again, is negative 6. Now I'll graph my other 2 points. Negative 4, negative 6, and negative 2, negative 6. So I have my points. Now I just have to make sure my graph looks how it should. Make sure it looks like a U shape. Don't make it look like a V or anything else. It does not have to be perfect. I can guarantee you that this is not perfect, by far. But is it a U shape? Yes, it is. Something like that. That's all I need to see for you to get full credit. Your 3 points, the correct shape. 18th, same process. Graph the following function. F of x equals 2 times the absolute value of x plus 6. Start with your parent graph. Know what it looks like. So it would just be the symbol. So we have y equals the absolute value of x. Think about the shape. That's important. Absolute value, V for value. This has a V shape. Make sure it looks like a V on your graph, not a U. Now we have to find our 3 points to graph. The first point is the vertex. So if our equation is y equals 2 times the absolute value of x plus 6, our vertex comes first from the inside number, inside change, so we're going to change this to a negative 6 for the vertex. Outside, there's no number here, so we think of this as plus 0. So 0 is my other number. That's my vertex. Negative 6, 0. You can graph that. And then we just need 1 point. Why did I graph that so off? 1 point to the left and 1 point to the right. So 1 point to the left is going to be negative 7. And 1 point to the right is going to be negative 5. Now to get my y values, I just have to plug these in for x and solve. And by the way, you don't need to include the plus 0. So I'm just going to be doing this one up here. X equals negative 7. 2 times the absolute value of negative 7 plus 6. Be very careful with absolute value. A lot of you guys like to just drop it immediately. Don't do that. Negative 7 plus 6 is negative 1. This is important because the absolute value of negative 1 is positive 1. So this becomes 2 times 1, which is just 2. If I made this a negative 1, I'd get negative 2, which is not the same thing. Now let's do that again. X equals negative 5. 2 times absolute value of negative 5 plus 6. Hold on to those absolute value signs. 2 times the absolute value. Negative 5 plus 6 is positive 1. Absolute value of 1 is 1. So again, we have 2 times 1, which is just 2. So again, we get 2. Let's graph our 2 new points. Negative 7, 2, and up 2. And then negative 5, 2. Again, this part's important. Make sure your shape is correct. You could easily make this a U if you wanted to, but this is supposed to be a V. So it's going to look like that. Clearly a V shape. Number 19, I want you to put a star by this one. This one's really important. This is the question that concerns me the most because it is a little bit tricky. Which of the following equations could represent this graph? This is an exponential function graph, and it's not labeled for you, but we do have an asymptote here. It's what is making this go flat. It's on -4. So I'm going to draw this in because they did not do that for you. I like to do this in highlighter because it's not actually part of the graph. It is, but it isn't. Like if you don't draw it, it's not a big deal. But you want it in there. So our asymptote is at y equals -4. It's that line. That's the asymptote. Now, if you remember talking about this in class, the number at the end of our exponential function is the asymptote. So we want -4 at the end of our equation. So right off the bat, we can get rid of C and D because our asymptote is not at 3, that's up here, and it's not at +4, it's at -4. So it's A or B. The one surefire way to know which one is the correct answer is to plug in a number and make sure that whatever you get matches what's on the graph. So the easiest number to plug in is 0. I will caution you on this. Remember, when you plug in a 0 to an exponent, any number to 0 power is 1. So let's review that really quickly. If I have 1 to the 0, it's 1. If I have 5 to the 0, it's 1. If I have 100 to the 0, it's 1. You get the idea. Just to make sure you really understand it, I will show you what this looks like in the calculator, which is something you can do as well, if you don't believe me. Or if you get to test day and you forget what it is, this is an easy way. So we have, just do 3 to the 0. It's 1. This is the easiest thing to plug into any equation, is 0. So I'm going to plug it into A, see what I get, and then I'll plug it into B and see what I get, and compare. So for equation A, if I plug in 0, for x, and let me do this with y equals. This makes me feel better. Y equals 1/2 to the 0 minus 4. 1/2 to the 0 is 1. 1 minus 4 is -3. So for A, I have the point, if x is 0, y is -3. Now let's do it for B. I have y equals -2 to the 0 minus 4. Now remember, when we do the exponents in here, it is kind of a big deal. The negative is outside, so I'm not going to have the negative inside when I'm doing this math. So this becomes 2 to the 0 is 1. So this is -1 minus 4. -1 minus 4 is -5. So for B, I have 0, -5. Now let's come over to the graph and see if x is 0, what is y? So 0 for x. I find the graph, it is right here. I have the point 0, -3 on my graph. If I graph 0, -5, that is out of sight, but it's down here. That is not part of the graph. That is not on the line. So B is not my equation. A is. You could plug in a different number if you're not comfortable with 0. You could plug in 1. This trick will still work. The downside of it is, of course, this fraction. Not a huge deal, but it's just not ideal. So if you want to plug in 1, you do the same thing. The point for B would not be on the graph, but the point for A would be on the graph. So just putting that out there. Backside. Number 20. Which equation shows the transformation of 8 units up, 7 units to the left, and a reflection over the x-axis of the parent function, f of x equals a times x minus h cubed plus k? That's a lot. Let's kind of translate this. 8 units up. Up or down, that's a K movement. So K equals 8. Up is a positive movement. 7 units to the left. Left or right is H. H is, left is a negative movement, so -7. And a reflection over the x-axis. Reflection is a negative A. So a negative in front. So let's process eliminate our way through these. We can automatically eliminate C because there's no negative out in front, like there should be. Looking elsewhere, A. It did not say anything about a stretch of 2, so automatically. Here we're left with B or D. Now we were nice to you guys here. We could have made this a little bit more difficult with the signs. K is 8, and here's the K spot. It's on the outside. K is not 7, that's H. So automatically our answer is B. Now we could make this more difficult. I just said that. So if you're not sure, you could always plug these all into the equation and then find the equations. Let's do that really quickly. If A is supposed to be negative, remember you just put the negative sign, don't put in an actual number, just understand it's 1. X minus H is -7 cubed. K is 8, plus 8. The only thing we have to fix here, we have 2 minuses in a row, which make a positive. So we do end up with this equation, -x plus 7 cubed plus 8. So if you're having trouble finding your equation, plug everything in, get your equation, and then find the one that matches. Number 21. Write the equation that shows the transformation of 5 units to the left and 2 units down of the parent function. F of x equals a times the square root of x minus h plus k. So we are transforming this function here. So let's go back through these transformations. Transformation of 5 units to the left. Left or right, that's an h movement. 5 units to the left. Left is negative, so it's -5. And 2 units down. Up or down, that's a K movement. So we're looking at K. Down 2 is -2. Those are the only transformations. So now I'm going to plug these into my equation. They don't give us an A, so A is 1. So we're just going to drop it. Square root. X minus is always there, minus h is -5, finish the square root, k is -2. And then we can simplify this just a little bit more. Square root, x minus -5, 2 negatives in a row make a positive, so this is just x plus 5 minus 2. And that's my answer. Number 22. Given the following function, f of x equals -1/2 x plus 8 plus 1, state the transformations. There is a lot going on here. So let's talk about it. Negative, this means reflection. 1/2. This is a compression. Remember, if it's smaller than 1, it's a compression, not a stretch. Plus 8. Remember, we interpret this as the opposite. So this looks like a right, because remember, inside is left or right. This looks like right 8, but remember, we do the opposite. So this is left 8. And then the outside number is up or down. Plus 1. We read it as it says, up 1. This is nice, so then you're going to avoid any traps that we've set for you. You could just read through and find the correct one if you want, but doing this work beforehand will keep you on the right track. Shift 8 units left, so far so good. 1 unit up, yep. Reflect over the x-axis, yep. And compression of 1/2, yep. That's correct. This feels like too good to be true, so I'm just going to go through the others to make sure I'm not missing anything. 8 units down right off the bat. No, there's no down, let alone 8 units down. 8 units left, yes. 2 units up, nope, it's up 1. D, 8 units to the up. I don't think they meant to write that. 8 units up, again, no. It's 8 units left. So we didn't make these too terribly bad. If you know what you're doing here, you should be good to go. You should be able to find the right one. 2 more. 23, given the following function, f of x equals 3 times x minus 1 cubed plus 4. State the transformations. Again, pick out the parent function first. F of x equals, it's our symbol here, x cubed. This is cubic. So now we're looking what changed between the functions. There are 3 changes we need to discuss. First is that number 3 in front. That number 3, we call it a stretch. Technically, it's a vertical stretch. If you write stretch, it will still be okay. Vertical stretch of 3. That's what it is. Next, we don't just have x, we have x minus 1. Inside here means left or right. This looks like left 1, but it's actually right 1. Remember, that one's the opposite of what you think. We interpret this as plus 1, so right 1. And then we have plus 4. This you read as it says. So if it's a plus 4, and this is up or down, if it's plus 4, it's up 4. You don't have to change anything there. Again, a list like that will work. If you want to write it out, it's like commas with commas separating, you can do that. Whatever works as long as you have the right transformations down. Be careful not to add any extra transformations. If you accidentally add reflection, for instance, I will dock some credit if you write down a transformation that is wrong, even though the rest of your answer is right. So just be careful with that. 24, given the graph, write the equation. First thing you want to do here is figure out what type of function am I working with here. This is absolute value. So the function I'm working with is f of x equals absolute value of x. That's kind of a starting point. Now I'm not nearly finished, but this is a good area to start with. Next, let's work with the vertex. If we put the vertex in here, that will help. Now, I'm actually going to write out the general form. If you don't have that memorized, not a big deal. You can find it elsewhere on the study guide. Yes. So the only place I can find it, unless it's on the back here. Yeah, the only place I can find it is on the very front page. It's right here. So I'm going to copy that down because that's kind of like the template I need to follow. F of x equals, one change I'm going to make is I need to put that a in front because I need to consider what a may or may not be. Minus h plus k. So I need to figure out what's a, what's h, what's k. If you remember from the notes video, I prefer to do h and k first. A is something I like to deal with last. So h and k come from our vertex. Our vertex is the top here. It's the top since it's upside down. Point. This point is 3, 4. That's our vertex. So, and remember this vertex is h comma k. So h equals 3 and k equals 4. So I'm going to plug those in. I'm going to leave space for a. X minus is always there. H is positive 3 plus k is positive 4. So I just found those numbers. And again, now that looks like a negative 3, but we understand it's actually a positive 3. A, let's figure out what A is. A is like slope. Absolute value is the best function to work with because it actually does have slope. It is a straight line, so we can follow it. Rise over run. So let's find our next solid point. We want it to go through the bottom right corner of the box. So we go through the line. Nope. Nope. Yes. Here's our next solid point, 6, 2. Let's find the slope, rise over run. So we go up or down, so we're going to go down. This is down 2, that's a negative 2. And then we go right 3, that's a positive 3. So here, A is negative 2/3. That's my equation, so I'll write it up here. Negative 2/3, absolute value of x minus 3 plus 4. And I am done. All right, this study guide covers a lot. Covers the transformations. We ask you all different types of questions with it. And then also mainly covers graphing as well. Please watch this as many times as you need to, especially for specific problems. If you have any additional questions over specific problems in the study guide, feel free to ask them when you see me in person or via email if you would like to get an answer pretty soon. Otherwise, I hope you have an awesome day, and I will be seeing you guys later. Bye!